And I'm here to talk about the ML work at Rent the Runway. But first, I want to orient people to what we do. Maybe 50% of the audience is familiar, but we really don't target the other half of you. So Rent the Runway started a little over a decade ago, where our first offering was giving women the option to reserve a dress for a couple days at a time for big events where you might not want to own that dress and wear it many times in a row. We've all thought, hey, I don't want to be photographed in that same fancy dress more than one time. Brilliant idea. Expanded it over time to a subscription offering. So instead of just buying prom dresses, wedding guest dresses, we have everyday attire now, and we have people renting for based on a subscription model. So instead of coming in very spiky patterns, maybe just around your holiday party or for that summer wedding season, people are coming back almost every day looking for, what should I rent next? What am I going to wear to the office tomorrow? What am I going to wear to the gym or on my ski trip? And then most recently, during COVID, we launched the ability to buy pre-loved clothing. So it was always possible for somebody to buy something if they had it at home. We didn't want to rip it away from them if they really loved it. But we were seeing a real shift in demand, and we wanted to be able to respond faster to moving through our inventory. And so now, like any other resale website, we offer the ability to buy directly from the site. And so all of these are really interesting data problems that we get to work on. And I'm going to start with an orientation to some of the data we work with. So starting at the bottom here, every style on our site, of which there are tens of thousands, we have a number of structured attributes describing these. And some of these are defined by experts, like the buyers and the merchandisers who are bringing this inventory into the site. Some of them are defined by machine learning models and by my team and other data science teams. So I'll talk more about those. Also, fashion is very visual. So the visual signal of looking at this style is a different experience than just reading all of the attributes describing it. So like, I could tell you this is the Dreamscape Camilla dress. That doesn't mean a whole lot. If you filtered for multicolored, it would show up, but it's really mostly browns and reds, and that's a completely different piece of knowledge than just that one phrase, multicolored. Another piece of data that we're gathering that is really meaningful for us is these on-site and app events. So somebody mentioned earlier, well-instrumented experiences are really valuable for getting feedback. Yes, they are. So this is things like what I'm showing here is the ability to heart a style, which means you like it. You can save it to shortlist, which you might add descriptors to, so that metadata of what other styles are in that shortlist, what's the title of that shortlist, and also how long are you spending looking at this? Are you scrolling right past it? Are you hovering? Maybe it caught your eye. Are you clicking into it? Are you spending a lot of time on the page before deciding whether you're going to rent it or not? Are you ultimately adding it to your cart? And then last but not least, one thing that's really exciting for me, I really enjoy working in that bits and atoms kind of mix, is people are actually wearing these clothes in the real world, or not. They're putting it on their body and they're saying, this doesn't work. And that's super useful feedback. So after every single rental, we're getting feedback from a customer about how she wore it, what she wore it for, whether it fit her, whether she liked it, how she felt. So I'll get more into that, but that's this example here is we're actually showing a curation to somebody based on what they've loved in the past, which sounds kind of boring, but it can be a real time saver. So some other data comes from our customers. We're collecting reviews in addition to this survey we send out. This is completely voluntary. Almost 2/3 of our customers have left at least one review. Almost 2/3 of our reviews have a photo attached. All of this is optional, and it's a mix of structured data, things like where did you wear it, tell us about you, tell us about your experience with it, how you felt, how it fit, but also unstructured data, including that photo I mentioned, and then free text where they can write about their experience renting the product. So there's a lot. I'm looking back at the other presentations we've had today, and I'm thinking I could learn a lot from some of them on more we could be doing here, but we're dipping our toe in and starting to learn some interesting things and putting this data to use. So at Rent the Runway, this data is really powering everything we're doing. I'll start up at pricing here. When we bring a style on site, it's a pretty simple algorithm. It's similar to every other retailer. We're looking at what is the cost, that our wholesale cost of acquiring it, and then also what would the brand or the designer have listed it at. And that's pretty much how we set our price initially. But then we merchandise it, we put it in front of our customers, we track this data on how they're responding to it, and that gives us more information about who we should be putting it in front of, As people browse, we'll put more out. We might switch what warehouse it's in so that it's getting in front of the right people. We might change the price based on the demand we're seeing. We don't want to sell something that people are going to keep renting for a really long time. And then once people wear it, they tell us, again, we have this data about their rental, and then it gets back to the warehouse. And when the clothing gets back to the warehouse, there's a ton more data. Does it come back damaged? What kind of treatment do we need to do to bring it back to pristine, rentable condition? How can we algorithmically route it through all the different possible stations to keep it in good shape so that we can keep re-renting it, make sure people have a great experience with it over and over? So it goes through that cycle many, many times throughout its life, and we keep changing what we're doing with it based on what we learn. So the data team that's doing all of this, I find really interesting work, has 4 main skill sets. The machine learning engineering team is the one that I spend the most time with, but we're a pretty collaborative group. So ML at Rent the Runway I think of as a full stack ML team. We're defining problems, working closely with our business stakeholders, building the models, and then ultimately we're putting them in production, which sometimes means an online service held to the same standards as any other eng team. Sometimes it means it's a batch model that's running on a schedule, and we're serving those results through some other means. Data scientists, we have a healthy overlap with this team. They're running batch models as well. We might be collaborating on what should be in an online system. They might be helping us measure the impact with online experiments, and they're doing a lot of ad hoc advanced analyses to help us answer the hard questions that drive our product roadmap. They're doing a lot more besides that, but that's where they touch my work the most. Our BI team is really the front lines with our business stakeholders, so making those really reusable reports and dashboards that give people a sense of how things are tracking and give everybody else the space to dig in on those one-off questions. And the data engineering team is really building the platforms and making sure we have the pristine data and the tooling we need to get that done. So, like I mentioned, really collaborative team, and that's led to some pretty interesting projects over the years. But I'm going to start with the ML projects. This team was really founded to primarily work on personalization. So you can think of a company like Spotify or Netflix, which has huge teams working on personalization, because as a subscription company, it's a really important feature for driving user stickiness and making them feel like what they're paying for is always changing and it's really valuable to them. E-commerce is another place where you see a lot of recommender systems, and we're kind of at the nexus of the two of those. I think of our problem as potentially more interesting than either individually. We have to keep people interested as subscribers, but no two people can stream the same dress at the same time. It just doesn't work. So we're optimizing not just for what you're excited about, but also who is more excited about it and who should it really be in front of. So we started with basic collaborative filtering models a few years ago. We've elevated over time to a LightFM model, which came out of List, a company. There's a great paper that they put out. This is still pretty old, actually, but it does a good job of tracking what I mentioned earlier, the on-site feedback. What are people hearting? What are they putting in their cart? So essentially, we're getting here an understanding of what people are responding to based on what they're seeing on the site. And why we switched to LightFM is there's the ability to also add metadata around the customer and the style. So this isn't just matrix factorization on the interactions, it's also telling us a little bit more about who are Ada and Beyonce, as if we didn't know. The real-world feedback is a completely different animal, and it really helped us add another layer to the way we personalize, because what you like and what you think looks great online doesn't always work out. So we send this survey to people after every single rental, and the first question we ask is, did you wear it? And if you wore it, we want to know how many times. And if you wore it, we also want to know, did you love it? Fantastic. Did you like it? Was it just okay? And if you loved it or liked it, we'll say that's a good result. You wore it, you loved it, you liked it, you were happy. If you didn't wear it, or if you said it's just okay, that's unhappy, and we want to know more. So this top row here, we have almost 100% answer rate because you can't do your next rental until you answer it. And we've tracked the data. It's pretty valid. Our community is really engaged. They know the value they're getting from others answering these questions. And so that's a super dense, high-value data set. And then as we move down, we get sparser, but the richness is really, really interesting. So these questions on what's wrong go into things like, did it not fit? Was it just not your style? Was it not flattering? There are some other ones here that are like feeling-based, right? Was it itchy? Was it damaged? And then even within this, we can understand specifics on fit problems and get to know more about that user and what specific challenges they have. We have another space for unstructured feedback here. The reviews are what I mentioned before, but comments are another space where we might get unstructured feedback from the customer. So a lot of ways for them to talk to us, and we're getting a lot of volume from these channels. And we started using this data to build another model that we put into our recommender ensemble, predicting the probability that someone will not be interested in or want to rent something, but if they do rent it, will they be happy with that rental? So this is based, again, on data about the interactions between people who have had a rental and how they responded to this happiness survey. It's also metadata about the user, metadata about the style, and then about the rental itself. So what time of year did it happen? Which SKU was it? There's a lot we can learn beyond just the person, the style, and the on-site. So this was super high impact when we deployed it. I'm not going to go into too much detail on the experiment there. Practice this, okay. But one of the things we learned was that size was a really big predictor of happy. And so this brought us to our next set of projects, which was how can we help people choose the right size? And we started looking again at a neural network that learns the relationship between what is the true size of a customer and what is the true size of a piece of inventory. So to orient you to this graph, each of the colors shows the size that a brand or a designer told us was associated with a style, but then their overlap in space is what our model learned as a latent embedding of what the true size is actually in the customer experience based on the feedback we've gotten. So there's a lot of overlap here. I don't think this is surprising for anybody. You might have tried on two dresses that are given the same size and had one of them fit great and the other one really feels terrible. So this was a really huge insight, and there's a lot that we think we can do with this. Like I mentioned, our first use case is trying to match what's the best fitting size for you for a given style, which means we also need to know what your size is. Unsurprisingly, way less beautiful visualization here. You think designers and brands have high variability in how they put sizes. Users have a ton of variability in how they want things to fit. Maybe I like things to fit loose and you like things to fit really tight. Maybe you've changed size over the last few months and you just didn't update it on our platform, so we're really out of date. Maybe you're never going to update it a few years later, like a friend of mine who just really can't bring herself to make that change. And that's super problematic if you want good recommendations, unless there's a model learning what your size really is today and kind of just tells you, hey, you should rent this size, even though it's really different than what maybe you put into the filters. So the way we have this operationalized, again, we're making predictions on what size someone should rent. Would love to talk more about that experiment, but I'm going to keep going in the spirit of this talk, which is not the specific use cases we've had here, but what we did after the fact. And so the last model I'm going to talk about is, I mentioned earlier, fashion's very visual. You can't really get away with running a fashion company without knowing about what your inventory looks like, which makes me a little sad this slide is so hard to see. But this is a pre-trained ImageNet model, transfer learned on images of our inventory, that's helping us map the similarities between them in space. And this is something that we can use, again, for a lot of downstream purposes. Originally, we built it, the first use case in mind was, can we, when we have a new style that we're onboarding, can we use it to extract attributes from that? And instead of having a human paid a lot of money to say this is red and this is orange and it has ruffles and it is an A-line, can the model do that better? And in some cases, the answer is yes, and that's excellent. But there's a lot more we can do here. So I mentioned earlier our full stack ML team, the way we think of it is that we're putting models in production in two different ways. So in this little visual, what I'm showing is we're pulling data from Snowflake, we're using AWS to train our models, we're storing models on S3, we're serving them in GCP. The whole thing's orchestrated by Prefect. That line is in the wrong place, but that's our stack, and then we serve it to the customer. This works really well if you just want to watch your model operate in production, but you don't want to know anything about it. If you want to know more about it, you'll have to wait a few slides because I jumped the gun. So this way of putting models in production serves our online use cases, like what do we recommend that you pick for a rental, or if we add some business logic on top of that, what should you pick if you're going to buy something? It's not just on carousels, it's also sorting every grid. And then if you zoom in and look at a specific product page, it'll also give you this size recommendation that I mentioned. So these are just a few examples of predictions being made on the fly every time somebody visits any page of the site. But these offline models are really important for us as well. And the way we're running these is we'll do the same training job, same pattern, but then we'll hit that model and store the results in Snowflake, and then there's some business operation, or I have this generalized handshake emoji here because it differs by product, but some other way that we're putting that into a decision process or in front of a customer that's not an online way. And so from here, because now we have predictions, and in some cases we started adding metadata in Snowflake, we started putting a lot of monitoring in Snowflake. We already had these pipelines and patterns built out, and we started realizing that this was a good way, a good way for us at least. I know there are a lot of tools out there now that are probably a lot lighter lift, but to build monitoring and evaluation on our data and get to understand more of why predictions are being made. So we spend a lot of time doing this, and the more data we put in Snowflake, bummer, this always happens with the people emojis, but our data scientists saw data, and what a data scientist does when they see data is they pull it and they start looking at it and thinking, what can I build and what can I learn and how can this be fun and interesting? And they started doing that with Snowflake, just with SQL, and then started working with Python. And they were coming up with some really interesting ideas saying, hey, I work on these other problems, and you're working in a similar space, you're learning interesting things, and I think this would be valuable for me. And their stakeholder, so I guess an example of this, one of the really important models that our inventory data science team owns is the future rental model. So how much longer is the lifespan of this product? How many more times is it going to be rented out before we're going to see the demand drop off? Or is it going to be worn out by too many washings or customers wearing it for, I don't know, events that ruin clothes, which does happen. And this historically was based primarily on time series data, a little bit of user data, but our data science team saw what we were learning about user tastes through our personalization algorithms and about our size models, and they said, that's a really good predictor of how the demand will change over time. And if we know who our user base is going to be over time, we can say what they're going to want, and we can also say how hard they're going to wear that inventory out. They also brought these ideas upstream and said, okay, if we can solve this downstream problem of when we retire a piece of inventory, if we know how we're going to merchandise it on the site, upstream is a way higher impact. Getting the right clothes on the site is sort of the root of all of these challenges downstream. And so serving the same information up to our buyers, they started here with our vision model. So doing an approximate nearest neighbors search to find the most similar styles to something that the buyers were considering. So in the past, I kid you not, our buying team would have a giant whiteboard full of sticky notes and photographs, and they're saying, like, I think this one we should buy X number of. And over time, we've been adding more and more data to this process, but this is definitely the most advanced it's been. And I think the quickest advance we've seen was this data scientist having this idea that, hey, I can work with embeddings too. So these are just a few examples. I could get into more, but I want to talk a little bit about some more data that we have coming up soon. I talked a lot about how users and inventory interact, but we have warehouse operators too, and they're interacting with the inventory as much as a customer is. And what they're doing is cleaning it and repairing it and sending it through all these different processes that really shouldn't be the same way you do your laundry differently. We're treating stains differently. We're treating different fabrics differently. So you can think of this as, can we find a way to match each style or each problem to the best way to fix it to optimize for the longest lifespan. So our product team really just launched this in December. I'm really excited to have enough data to start working with here because we have a lot of ideas on what we can build and how that, again, could inform other models downstream. And so these data scientists are playing with this, and I've told you about a couple of the specific use cases that they've found, but the stage we're at now is thinking about how can we accelerate this process of innovation on top of what was once a pretty, I would say, like tight garden. And we know that they use similar tools to us in some cases, right? We're all Python users. But their stakeholders are really different than ours. Our stakeholder is another engineering service. If it can read our outputs, we're happy. Their stakeholders are primarily business people. Maybe they're fashion people, they're very visual, they want to see things, they want to understand it. So there have been some conversations today about explainability. That really matters for this team. And that's pretty different from us. And so one thing that we maintain is a package of different utilities that make it easy to do things like pull data from Snowflake, pull images from our CDN and display them, hit models on S3. And what we're doing is we're adding more helper functions to this that do things like find the nearest neighbor of a set of embeddings, or find intelligent clusters that make it easy to understand who are the groups or what are the patterns in these embedding data to help you maybe target different marketing segments or make smart decisions about how we merchandise. That's on the data science side. We're moving in that direction. I think the BI side's a little tougher. Our BI team mostly works in Looker. I know a lot less about it. Feels like there should be some more opportunity there beyond TS&E, which I didn't have a great time explaining a few minutes ago, and I'm sure our buyers wouldn't love. So I'm looking forward to seeing what we can build out there, and just generally excited about seeing other companies doing this. I've read some papers about the idea of generalized embeddings, expanding the whole ecosystem. Somebody mentioned earlier how transformers, for instance, have unlocked our ability to do so much with less specific knowledge. And I think we're at that point now even more broadly. So that's where we are. And I'm excited to take questions.
I think we have time for one or two questions, and here's one.
Thank you. First of all, great talk. Thank you so much. Second of all, I might have missed this, but how exactly did you generate the user ID embeddings?
Depends which ones. So I hope this back button does something. Well, the primary ones that we use today are the user embeddings that come out of, I'm just going to stop. So the Light FM embeddings, like that, I do recommend that paper because that algorithm was built with the idea of being able to pull these embeddings out to understand how a style relates to others in space and how a user's tastes relate to others in space. And that's a really helpful concept for us that we can apply in a lot of different places. So that's the primary one we use. There are others that we're looking at. One of the interesting ones that we're starting to think of is, again, a user trail of activity and like, well, how do they tend to behave on site? And can we use that to inform when we might intervene if they're about to make an action and we want them to continue? I could keep going, but.
So you would then kind of like structure data about the user, not just like the ID, obviously.
Right, so the primary component of the embedding is the set of interactions that they've had with all of the inventory over a given time period, and then it's contextualized by data that we know about them that they've either input or that we've learned. Absolutely.
All right, thank you so much. Oh, we can leave that up here.